Okay. Oh, and what we have discussed in the last class means all the functions of the static routing we have discussed, correct? Now we'll discuss what are the methods we have to configure the static routing. Different methods to configure static routing. Now for that, understand one scenario. First we will take is directly connected static routing. So we'll take here two router. This is router 1 and this is router 2. Between router 1 and 2, we have one common network that is 192.168.12.0 and /24. And this side, we have one network, let's say 2.2.2.2/20. Okay. It means one IP we have configured on the loopback interface, correct? Now from router 1, you have to reach this particular 2.2.2/24. And on this interface, let's consider this is a G0/0 and this one is G0/1. Or this can be also 0/0 only, no problem. Okay. Now here we have one IP. Let's consider as 12.2. And this side we have one IP 12.1. Correct. Now you want to reach from router 1 to this particular network 2.2.2. See, this is not the network, this is a IP. So network address will be what? 2.2.2.0. Okay. So here the command will give it IP route to reach the network that is 2.2.2.0 with a subnet mask. Let me write in small form only. IP route 2.2.2.0, then 255.255.255.0. It means first what we are writing here, network address where we have to reach and the subnet mask of the network address. Then after that you will write here G0/0. This is what? Exit interface number. This G0/0 we are writing the interface number that is associated with the router 1. That, okay. So what it is called as a exit interface number. So when you are writing only one command that is exit interface number, then this method is called as a directly connected static routing. Now, what is the problem with this? See, here you are telling that you have to exit from this network to reach particular this network, but you're not informing router 1 from where you have to enter this network. It means you are giving him incomplete information. This is not the complete information. Just you are telling that you just exit from G0/0 to reach that network. You're not informing him that from which interface it has to enter to reach this particular network. So here there will be no any problem. The reason because here it is point-to-point connectivity. They both are directly connected. So it will reach, it will ping also. And it is also a type of static routing. But problem is that in this type of method, always it generates ARP request. It means it asks, who has this particular network? Tell me so that I can reach there, right? So in this method, always, or we can say in this method, ARP request is generated for each packet to know the the destination address. So see, okay, for example, let's say for the first time we are pinging, then it is fine also. But every time if multiple PCs are there, let's say with the router one, we have a switch, and with that switch, multiple PCs are there. If all that PCs starts trying to reach this particular network 2.2.2.0, what will happen? Every time ARP request will be generated. So means work of this router will be increased, CPU utilization will increase, right? So all this multiple problem we have, correct? So you can correlate this scenario with one example. Let's say you want to go from NH to Electronic City. Okay. So I told you that you have to go out from this gate number one. But when you will go out, you have multiple options. You can go any direction. I have not informed you know that in which direction you have to follow. So you can again, this is incomplete information for you. Just you know that okay, I will be going out from this gate number. But once I am coming out from this gate number, in which direction I have to go? You don't know. So what will you do? You will start asking for the information. Now tell me where to go, right? Same thing is happening with this type of method when you give directly connected static routing. Here just you are informing what? Only one information, exit interface number, right? So what we will write in the actual commands? Command for it is IP route. Then first we will write here destination network address. Destination network address. Then we will write here subnet mask and exit interface number. Correct? So as this method is having a problem, so we have one more method. Method number two. Same scenario. This time, instead of using this particular exit interface number, what we will do? We'll use next hop IP address. Routing using next hop IP address. Now, see, same scenario is there. Now, what will you do? You will give the command IP route. You want to reach same network that is 2.2.2.0 with a subnet mask 255.255.255.0. And this time what you are doing, no, instead of giving this exit interface number, you are writing next hop IP address. That is 192.168.12.2. What you did? Again, you did the same thing. Incomplete information. What you're telling the router one, that C router one, if you want to reach this network that is 2.2.2.0, then you have to enter this network using 12.2. Fine. What will do here? What is the problem here? Here the problem is recursive lookup. Now what is this recursive lookup? In this, the router will check its routing table multiple times, or we can say two times. Why? First, it will check, okay, that you are giving him information that I have to reach this network via 12.2. First time it checked. Second time it will check, okay, how to reach this 12.2. So it will come to know that, okay, this 12.2 is in my same network, means same directly connected network. It means I have to exit from G0/0 to reach this 12.2. And then I have to reach this particular network that is 2.2.2.0. It means the router has to check its routing table two times. Again, if you will correlate with the same example, now what I told you that you want to go from NS to the electronic city. This time, what I am telling you that you have to go out, go to this bus stop, take a bus to reach there. Then let us let me if this NH is having multiple exit point, then again you will ask from which gate number I should exit. Again, it is like an incomplete information, correct? Just you are informing him that, okay, to reach this particular network, you have to enter from this particular next hop. But you're not informing him that how to reach this particular next hop only. This question will be asked from the router, how to reach this particular next hop. And it is going to enter from what? This particular interface number, exit interface number. So when you're giving this particular information, what happens? It will cause recursive lookup. So what command we are giving here? IP route, then destination network address, destination network address, then subnet mask, and next hop IP address. Same scenario. Now to overcome with these two methods, what is the solution? We'll prefer fully specified static routing. Fully specified static routing. It means here you will give both the information. So in the command you will write here IP route to reach network that is 2.2.2.0 with subnet mask 255.255.255.0. This time first we will give the information regarding the exit interface number that is G0/0. Next we will give information regarding next hop that is 192.168.12. Okay, so now we are telling that, okay, if you want to reach this network, first exit from this interface, next enter from this next hop. This will remove all the problems of multiple ARP request packet and also the problem of the recursive lookup because the information is present in the single command. Okay, so if you will write here, so it is going to be IP route, then destination network address, subnet mask, then exit interface number, and at last you will write here next hop IP address. Till here it is clear? Clear, no? Yes. So see, same situation is there. Router one we have, and this side we have a router two, and here we have one PC connected with this particular router. So PC IP is 172.16.2.9 here. And this is network is what? 2.0. So it is telling you that when we want to reach from router 1 to this network, the command it has given is IP route, the network address, the incident mask, and this time what it has given? Exit interface number, right? Only this one. And in the second one means to reach from router 1 to this network, that is 3.0, it has given what? Next hop IP address. This one, not this one, right? So one is what? Directly connected, and one is what? Using next hop IP addresses. Correct, no? So we'll take this topology only and we'll try to configure. Now, on this interface, we'll give one IP. Let's say here the network address is going to be 192.168.10.0/24. So here we'll take the IP as 192.168.10.1/24. This side we will take 192.168.10.2/24, right? Even if we will be having one network address at this side also. So consider here that IP we will give 172.16.10.1, or let's give it 10.2 only /24. Okay. And for this one, 172.16.10.3/24. Okay. On this interface, 192.168.20.1/24. On in this interface means G0/0, 192.168.20.2/24. Network address is going to be 192.168.20.0. Next, on this interface, we'll give IP 172.16.20.2/24. And here 172.16.20.3/24. Right? So here, like we have one network, and this side another network, one network, another network. This side, what we will do means directly connected, and this side using next hop IP. Okay. So first come to this router, CLI, give no, enable, config, HT. So what is the command we'll give? Host name as router1. We have two interfaces, G0/0 and G0/1, right? The first one is G0/0. This one is 0/1. Okay. See, whenever you have multiple devices, okay, so you have two options. Either you go on the individual devices, configure it separately, or you can use a notepad. Write all the commands in the notepad, copy, paste, copy, paste. Both is preferred. You want to show that notepad? Let me show. So this is router one, no? So command on router one, we will give enable config space T. What is the interface number? G0/0. Then what is the IP address? 192.168.10.1. Then 255.255.255.0. No shut, give exit. Now what will you do? Just copy and paste. Copy here only and one more paste. And this is going to be interface 0/1. What is the IP? 20.1. That's all. Okay. Now you just copy this, come to this router, give exit because we are starting from enable only. And just, are you seeing here, paste, paste. Then this will be helpful when you will start the routing, CCNP, because we will be taking more numbers of devices. So always going on the individual devices, doing the configuration will be very much difficult. Okay, so now you check do show IP interface brief. Done, configured. Now what you do, come to this router. Here also we have two IPs. So come to this notepad first. You just copy this, or just no need to copy, just make it router 2. This interface 0/0, so 10.2 and 172.16.10.2, right? 172.16.10. That's all. Copy. Come to this router, CLI, give no, paste. One more thing, host name, router 2. To show IP interface, if configured, come to this router, CLI. This is router 3. Then add a host name here, router 3. Interface 0/0 is 20.2. Change. Interface 0/1 is 172.16.20.2. Copy. Paste. To show IP interface brief. Configured. Done. Now you come to this end device, configure the IP. Desktop, IP configuration 172.16.10.3. And subnet mask is going to be 255 because /24. Now you tell me here default gateway is required or not? It's required because this is PC. We have to reach this PC from outside network. We have to get echo reply. So in that echo reply, it must have what? Default gateway. Who will tell me what is the default gateway for this PC? No, tell me a number, no, IP. 10.2. It means 172.16.10.2. Correct? Same as come to this PC. Desktop, IP configuration, 172.16. dot 20.3 255 dot 0. Default gateway is what? 122.16.20.2. 172.16.20.2. Then now you come to this router, ping, do ping 172.16.10.3. What will happen? It will ping or not? How it will ping?
No.
Different network to router, 0% it is. Okay, see here, how many packet the router is sending when you ping? 5 packet. In the Windows, how many packet it sends? 4 packets. What is the size of the packet here? 100 bytes. There, 32 bytes. Okay. Now we have to do here routing. So I am on the router 1. I will give the command IP route. I want to reach this PC. So what do I have to write here? Network address, where my PC is located. What is network address for that? 172.16.10.0, 255, 255, 255. And then what I have to write? What is that? Exit interface number G0/0. Okay. So right here, G0/0. What it says? Without gateway. If not, a point-to-point interface may impact the performance. It means it is giving us a warning that if point-to-point connectivity is not there, then what will happen? It will impact the performance. Okay, fine. Give exit. Debug ARP. Debug. Might be.
Routing table.
No. Debug. Question mark. IP standby. No. You will give up. It will not take. Fine. Let's debug ICMP. Debug. If we give debug packet. Okay, ICMP is on. Now you try to ping. To ping. Okay, ping to 172 16.10.3. That IP we want. See what it says. Echo reply received from the source 10.3. What is destination? 10.1. Right? Means echo reply you have received from where? 10.3. And destination is what? 10.1. Here also the same thing. Now, why it is having 60% loss? Sorry, 60% only. The reason because the packet is being lost there in the ARP request. It is generating what? ARP packet. That's why here only 60% confirmation is there. 60% packet is reaching there, 40% is getting lost. Now, when you will check with the command, show IP route. So see what is written here. What it is written? S. S means what? Static. It says that I can reach 172.16.10.0. How? Directly connected using what interface? G0/0. That's all. Okay. So S stands for static. Now see what is the C? C stands for connected. So in the connected, what is written? Network address. What is L? Local. In local, what it will write? Local IP address. Okay. With this router. Again, same. C network address and L is what? IP address. So this is important to understand that in the routing table, first thing how to check routing table? To check a routing table, will give the command show IP route. In that C stands for connected. It gives the information about the network address associated or connected with that particular route. Then what we have? Local. Local is what? It gives the information regarding connected IP address with that route. Then S means static. What is the AD value of connected? 0. Because directly connected network is most reliable for me. That's why AD is 0. After connected, most reliable is static route. That's why it is having the AD value as 1. The reason because /32, if you always you will find that IP address is going to be denoted by /32. It means that this is a single IP. Single IP means like let's say this is a device. It is having a single IP. To determine it, it uses always /32, a specific IP. Even if you want to reach, let's say you are using /24, okay, but you want to reach a specific IP in that network. For that, you want to reach a specific IP, then you will not use /24. You will use /32. Okay. To reach a specific IP, it uses /32. Clear? So here we have seen this means it is able to reach, but it is showing you what? Directly connected method, right? Now, this side, what we will do, we will try to reach the same 20.3, but this side we will use next hop IP address. So come to this router. Config space T, IP route. Then where we have to reach 172.16.20.0, then 255.2.0. 255.255.0. And this side, instead of using this particular exit interface number, we will use here what? Next of IP address, it is 20.2, this one. 192.168.20.2. So 192.168.20.10. Now you try to ping 172.16.20.3. It is pinging, same 60%, because for the first time here also it requires what? ARP, correct? Now, if you will check here, do show IP route. What is written here? Static, same, means it is telling you that if I want to reach 172.16.20.0/24, I am going to reach via 192.168.20.2. There is no any information how to reach this 20.2 in the same line, correct? Then it will check, okay, that as it is directly connected, so I am going to reach it via this interface. See, it is written no, just 20.2. So 20.0 is directly connected. So it knows that if I want to reach that network, I have to go out from which interface? G0/1. It means this information will be present in the routing table, but the router has to check it multiple times. Correct? And this is going to cause what? Recursive lookup. And here, if you will find, it is still telling you as 1 and 0. What does this 1 means? 1 means here AD value of static routing. And what is this 0 means? Metric cost. It means here it is not going to use any metric cost to calculate the best path. The reason? Because who decides that? Network admin decides that. That's why. So here we have found 1 and 0, right? Then again, you can verify with the command do show run in the section of routing. Do show run in the section of routing. That is not sorry. Yes. Okay. Do show run in the section of route. So it will show you all the commands that you have given for the routing purpose. Clear? Now, what you do, we will try to remove this second command and we'll try to enter fully specified. Okay. How will you remove that? See, just you give the command and in front of that you have to add no. Removed. Now you check to show IP route. See, no route to present to reach that 20.0 network. And even you can verify using do show run in the section of route. So only one command is present here. Correct? Now you want to add fully specified. So what command you will give? IP route. I want to reach 172.16.20.0 with submit mask as 255.255.255.0. What is the exit interface number? This one, G0/1. Okay. So we'll give that G0/1. Now, what is the next hop IP address I have to give? This one, 20.2. So 192.168.20. What it says. It means this fully specified command is not supported in the Cisco packet traces. Clear? Let me show you in the EVNG. Then after that, we'll do it on the real devices, but not today. As you know, server is down today. So this is how you can get like all this particular virtual machines and with that images of the devices is there in my laptop only. But in real scenario, what will happen? No, this all things will be located in a server, and you will get the IP address of that particular server to access. See, you'll also be getting IP, no? Like that, you will get IP to access that particular server. Okay, then it will ask you all the login credentials. You have to put that. Okay, the username and the password. You don't know, like, no need to know how to take all these devices. When you will come to CCNP routing, everything will be explained. See, if you will take this one, let me show you one thing. Each, if you will take one router will consume 1 GB RAM. Okay. And now come to more action, start all modes. Now come to router one. It will take time to start. Let it start. First, what we will give? No. Enable config space T, host name as router 1, interface G0/0. Everything is visible, no? In the background. IP address, okay, interface G0/0. IP address is 192.168.12.1 to Wi-Fi.255.255.0 and give here no shut, give exit. Okay, now you come to router second. Enable config space T, host name as router 2, interface same as G0/0. Now IP address is 192.168.12.2.255.255.0 and give it here no shut and give exit. Now we have to add that IP also, that is 2.2.2, where on the interface loopback. So interface loopback 1. Okay. IP address is 2.2.2.2 255.255.255.0. Give exit. Now verify do show IP interface brief. Configured? Configured on the loopback 1, right? Come to router 1, try to ping. Do ping 2.2.2.2. Not pinging because in the same different network. So what we will do here, we will do IP routing, but fully specified. Give IP route to reach where 2.2.2.0 with subnet mask 255.255.255.0. This time first we will give what? Exit interface number, that is G0/0. Next what we will give? Next for IP address 192.168. Okay. Done. Now you check to show IP route. What it says. I can reach this 2.2.2.0 network via 192.168.12.2 and interface number G0/0. And this is called as a fully specified static routing. We try to ping to ping 2.2.2.2. Yes. Pinging. Correct. Got the idea? What is this fully specified? Like it requires, but everything is in the background and all the information is present. That's like for the first time also. It got the 100% like. Clear? Understood this? What about online students? Clear it is? Confirm fast. Is it clear? Hmm. Means this one and this one. Okay. Hmm. Then again, we have to do one more routing, no? Between them also we have to do the routing. Okay, I'm giving you one scenario. Understand this scenario. This is one router. This is one router. Okay. Now between them, what happened? That you have two connectivity. Okay. This side we have, this is router one. This side we have is router two. Okay. Or better to give you good scenario. This is not good. We'll change this. Okay. One router, one more router, then one more router, one more router, and then we have a PC. Okay. Now between this, we have like this connectivity. This is router one. This is router two. This is router three. Or let's check. This is router three. Okay. And this is going to be router four. Fine. Here we have interface as G0/0. And here we have interface as G0/1. IP is 192.168.12.1. And here we have IP as 192.168.12.2. This side we have 192.168.24.2. This side we have 192.168.24.4. Next, here we have 192.168.13.1. Here we have 192.168.13.3. Okay. Here we have 192.168.34.3, 192.168.34.4, and this side we have one IP. Let's consider 172 or 192.168.50.1/24. For this particular IP, it means here we have 50.0. Now you tell me, don't you think that from router 1 to reach this particular PC 50.1, how many alternate option you have? Two. You can reach via 0/0 of router 1. You can reach via 0/1 of router 1, right? If you have given both the commands, then what will happen? If you will give here also one static routing, if you will give here also one static routing, then it will do load balancing. What is load balancing? It will send one packet via this one packet via this one. Let's say you have four packets. One packet this one packet this one, third packet this one, Fourth packet, this one by one. What it is doing? Load balancing. Okay. But if I want that, no, it should prefer only one path at one time. So how, what will you do? Let's us, we will give you one command, IP route. Then you have to reach 192.168.50.0, 255.255.255.0. And what you are giving it? Exit interface number G0/0. IP route, same 192.168.50.0, 255.255.255.0. And interface number is what? G0/1. In this scenario, both the routing commands that we have given is the best. Both the route is best. Correct, no? Both the route is best. So in the routing table, both the route will be present. When you will verify with the command show IP route, both it will show you that I can reach 50.1 via 0/0 also, via 0/1, because both are my best path. If both the path is best, what it will do? Load balancing, equal cost load balancing. Okay. Now I want that no, it should take only one path and one should be kept as a backup. What I will do? I will increase the AD value of one of the route. Let's say the down one. The down one, I'm making it just 10 I am writing. In front of the commands, at last I will write 10. If I will write 10, what will happen? AD value of a static routing will increase from 1 to 10. Now you know that whoever is going to have the least AD value is always preferred. So among these two commands, who is going to have least AD value? First one. So always it will prefer the first one. Always to send traffic to the 50.1. To send traffic to this 50.1, always it will prefer interface 0/0. Why? Because this is having a least AD value. If this interface is down, this link is down, this link is not working, automatically it will start sending the traffic from G0/1, right? In this, you can understand two things. One thing is that we can have a backup path to reach a destination. Second thing is that we can change the AD value of the routing, right? We can change. I have changed though. I have given here 10, correct? This method is called as what? Floating static routing. Floating static routing. You will understand this floating static routing in the CCNP routing. Okay, but in CCNA it is written to explain you what is floating static routing. Configuration will do in the CCNP routing. If you want everything I have given you, you can take this topology, you can try with yourself.
This can be done with all the three methods.
All the three methods. But as you will be doing the Cisco packet tracer, so go with this method only, exit interface number. If you are if you are able to reach from router 1 to this PC, then your static routing is completely confirmed. Okay, because here it involves multiple routing. First, you need to reach from this network to this network, then from here to this one. Okay, that's why. You can try from your side. But this is the method called as a floating static routing, where we will be having one of the route as a higher AD value. Correct, no? Yes.
Yes.
What about online students? Confirm. Unmute yourself and reply. Don't clap. Unmute and then tell.
Yes.
Yes, good. It looks participating, right? Otherwise, it looks very boring. Okay, so see, what is this AD value? AD value is used to rate the trustworthiness of routing information received from the neighboring router. So the router with the least AD value will be selected as the best route to reach a destination. remote network, and the route will be placed in the routing table. It defines how reliable a routing protocol is. So different routing protocol is going to have different AD values. And see here that directly connected network is having AD value as what? 0. Static routing, 1. EIGRP summary route 5. You will know about all these things later on. Then external BGP is 20. Internal EIGRP is 90. Then internal IGRP is 100. OSPF is 110. ISIS is 115. Routing Information Protocol RIP, that is 120. External EIGRP is 170. Internal internal BGP is 200 and unknown is 255, that is unreachable. Okay. You have to remember all the AD value of all the routings protocols. Okay. When you will start practicing, it will be clear. You will be able to remember that. That is fine. Clear till here? Same 192.168.12.1/24. On this side, we have 192.168.12.2/24. Here we have one IP 2.2.2.2, 22.22.22.22. Okay. So it means two different networks. Okay. If you want, you can add one more. Let's say 172.16.2.1/24. Okay. Now come and configure your devices. So come to router 1, CLI, give no, enable config space T. What is the host name? R1, interface G0/0. IP address is 192.168.12.1, 255.255.255.0. Give no shut, give exit. Done. Now come to second router. Then CLI, enable config space T, host name as router 2. What is the interface number? 0/0 only. Interface G0/0. What is the IP? 12.2. So IP address is going to be 192.168.12.2, 255.255.255.0. Give no shut, give exit. Then loop back. So interface loopback 1 is IP address 2.2.2.2, 255.255.255.0. Give exit. Interface loopback 2. What is the IP address? Let's say 22.22.22.22, 255.255.0. Exit. Interface loopback 3. IP address is 172.16.2.1.255.255.0. Give exit. It means total 4 IP we have on the router. Second. Now verify to show IP interface brief. All the IP has been configured on the loopback. Now you tell me that if you want to reach this network, you require one routing. If you want to reach this network, again one routing. If you want to reach this network, again one routing. It means 3 different network, 3 different route commands are required here. Let's try if you give here IP route to reach 2.2.2.0, 255.255.255.0 and G0/0. Then do ping 2.2.2.2. Yes, pinging. What about if you try to ping 22.22.22.22? What will happen? 0%. It means to reach a specific network at what requires a specific routing commands is required. So we have one more option. See what we will do. We will give here IP route. I want to reach any network 0.0.0.0 with any subnet mask 0.0.0.0. And same here also the same concept. Either you give exit interface number, you give next hop IP address, or you can give fully specified. So here just we will go with the directly connected exit interface number. We'll give 0/0. That's all. Done. Only one command you have given. Do ping 2.2.2.2. Pinging. Do ping. Pinging 172.16. What we are given 2.1. Pinging. It means that if you have n number of network this side, all the network will be reachable with the single command that is called as a default routing. Okay, this is called as what? Default routing. So you have not given any specific particular network ID. Just we have given to reach any network with any subnet mask. So if whatever the network it is coming this side, all the network is reachable for that. It means here we can say that this particular default routing works in a single direction. It means that in that particular direction, whatever the numbers of routing is means network addresses is coming, all the network addresses will be reachable with that particular router. So generally, we prefer this default routing when you have to reach ISPs because we are not aware about the network addresses on the ISP side. That's why we give this particular command at edge router, like the router after that ISP is there. Okay, default routing. So when you will check do show IP route, what it says S star. S star means default routing. Okay. All the information is given means regarding that I have to reach there where 0.0.0/0. Now let me remove this and I will show you one thing. Give no. Now you give IP route 0.0.0.0, 0.0.0.0. We will not give an interface number. We will give here next hop IP address. What is that? 12.2. Correct. So 192.168.12.2. Do show IP route. It can reach via 12.2. Now, I wanted to show you what is the AD value of default routing. What do you know? What is the AD value of default routing? AD value of default routing is 1. Why? Because this is also a static routing only. It is a part of a static routing, just method is different. That's why default routing AD value is what? 1. Write down for this default routing. So it is part of static routing where routes are advertised for any network with any subnet mask. With this routing, all the network coming under a single direction will be reachable by the router. Correct? Here the command we will give it as IP route to reach any network with any subnet mask. And next, same information, either you give exit interface number or next hop, or you can go with the fully specified also. Okay, now AD value of default routing is 1. Let's say if you want to deny any of the network. For example, here we are able to reach all the network. So now I want that no, it should not reach this particular specific network. Then again, we have to use one different methods to deny that. So even that we have to discuss, but it is not in a CCNA, it is in a CCNP routing. That is called as a null static routing. So when you will come to CCNP, 2 more points will be added. One is null, one is host, and one is floating configuration. All these 3.
It can only be used on edge routers.
Generally, we can say it can be used on any of the router, but generally we can say prefer on the router where we have to reach a network coming under a single direction. Correct? Understood this? So this we have completed static routing and default routing. Now you tell me what all the disadvantages and advantages of the static routing you know. First. Okay, first we will write the advantages. Online students, you have one advantage. You can use ChatGPT to tell me the answers. Advantage of static routing. First thing. Okay, how it is secure?
More control.
It is secure as all the control
Network.
is with network admin, right? Correct? It is secure as all the control is with the network admin. Second point. Okay, good. Less CPU utilization will be there for the devices. Huh?
Metric cost 0.
Metric cost 0, that it is fine. Metric cost 0, that's why we have less CPU utilization, because it is not going to do anything automatically. If it is used in the small network, I don't think it is an advantage. It can be a limitation. Then, please, online students, please be participative. Answer some of the other option from your side as well.
Easy to configure and understand small network.
Yes, easy to configure.
Static.
Manually configuration also. No, like
Okay, manually configuration, but I don't think that this is like a advantage. Already we have written here that it is in the network admin control. Then
Deep utilization, low resource usage.
Okay, we can say like that, no resources. Some more. Hmm? What testing?
Larger network, small testing.
Perfect for small and stable network.
Okay, it provides.
Reduce IP, IP address postage.
Oh, no. It provides a stable network configuration. Any other point?
Doesn't rely on routing protocol configuration and correction across the multiple routers.
Fine. It can come under this only, stable network configuration. Then another point. It is secure. It is having less utilization, easy to configure. It provides a stable network configuration. Any other point?
Cost. Costing.
Okay, fine. Cost efficient it is. Okay, then right, no problem. Yes. It is going to be cost efficient, right? Hmm. Now we'll write.
Bandwidth efficiency.
We can say means less bandwidth consumption, right?
Yeah.
Less bandwidth consumptions. Okay, so first let us write disadvantages now. What is the first point?
Complex implement.
It is applicable for the smaller network. It means it is not scalable. Third,
Manually
software
configuration.
requires manual configurations. Do not change the routing table automatically.
No load balancing.
Load balancing.
Network
It is
address
done.
should have only destination.
Correct. Destination address should be known.
But in both the cases, we have to know, right?
No,
Destination.
in dynamic routing, the destination address is not required.
Oh, sorry. Next hop ID.
Okay. Here, destination addresses should be known. Any other disadvantages? Okay, we can say everything is complex then.
Recursive, more mathematical confusion.
No. Any other point?
Multiple output based and recursive because
That is there when we are using multiple different options then. I'm talking about overall static. Okay, one more thing, you can write that no metric cost. Any other point? Tell me fast.
think most of the things we have, lack of
Mhm.
scalability, not suitable for large accounts. No automatic failover,
What are automatic?
failover, if it is the route
Ah,
link is
ah,
failed, the traffic is
that,
not
that's why
rerouted.
we have written here that it requires manual configuration to not change the routing tables automatically. It will come in that this part only. Ah, okay, right, no problem. Not suitable for large network. Just you are exchanging the words, that's all. Not suitable for large network or
Not
complex.
aware of network topology.
Ah, correct. Not suitable for complex network. Huh? Okay, then when you will come for the routing, no, CCNP routing, you have to tell me more points. So till that time, you have to inculcate your thinking capacity. Fine. So we are done with this static routing, default routing. And next we have to start with the dynamic routing. Okay, so we'll be starting with the dynamic routing the next class only. So just I will give you one topology you have to configure now only. So this is the configuration topology. See, you have to take this router 2911 series of the router. See there. Take two router. Then you will take two switches. Very simple topology I'm giving you. Then you take here two PCs only. Okay. On this interface, 0/0, IP is 192.168.10.1. For this PC, it is 192.168.10.2/24. Network address is going to be 192.168.10.0. Here we have one IP as 10.1.1.1/24. This side we have IPs 10.1.1.2/24. Here we have one IP as 192.168.20.1/24. This one is 192.168.20.2/24. And here we have one network 192.168.20.0. Okay. Condition is ping from 192.168.10.2 to where 192.168.20.2. It should ping. Use static routing with next hop. You will use with next hop, not with exit interface number. This is your task. Both the species would communicate with each other. Okay. So that's all for the today. Next class will be on Monday. We'll stop the recording.